So yes, an exponential function has an inverse because it is a one-to-one function. All right, and we have already talked about, and I know it's review, the inverse function of an exponential function is the logarithmic function with base a, and is denoted by log base a. So what I have here, the exponential function, rather than writing f of x, I'm going to write it as y. So y equals a to the x. So the inverse function, what I want to show you is if we use what we did yesterday, when you're writing an inverse function, you switch the x and the y. So if I switched x and y, I would have x equals a to the y. That is the inverse function, but we write that as a logarithm. So this is equivalent to log base a of x equals y. So if you converted a logarithm to an exponential equation, it would be in this form. And Mrs. Holba may have said this last year, but I made a note of it on here as well. So if x is greater than 0, then log base a of x is the exponent to which the base a must be raised to give the value of x. So what this is showing, log base a of x is equal to y, and in exponential form, y is the exponent. So when you're solving a logarithm, you have a base a, you're thinking, what power do I raise a to get x as my answer? So it does give an example, or I have one typed here, and then I have a couple of examples for us to talk about, so just we have that understanding of logarithms. So if you saw log base 10 of 0.001, this is equal to -3 because 10 to the -3rd power is equal to 0.001. So I tend to kind of draw arrows this way. 10 to what power equals this, and then you're trying to figure out what that power is. Yes, I know we have calculators. Calculators can figure out the logarithms for us, but it's good for you to have an idea and an understanding of what your calculator is finding and how your calculator found it. So I do have two examples here. I'll find the exact value. So log base 2 of 8. So I could even say equals y or equals whatever. So what I'm looking for 2 to what power would equal 8 is what this really means. 2 to the y power is equal to 8, and I need to figure out what that power is. So what is y? 3. So this logarithm would be equal to 3. And then example B, log base 3 of 81 would be 4, yes, because 3 to the 4th power is 81. Questions? All right. So I've included in here what I have next, cancellation equations. These are used a lot, and there's cancellation equations I have in the note sheet as well, specifically when you have the natural logarithm. But these are used a lot when you're solving equations that involve logarithms or involve exponents. So if we had f of x is the exponential function a to the x, and then its inverse, f inverse, is log base a of x. So the cancellation equations we learned yesterday, when you take the inverse function of the original function, f inverse of f of x. So this is what it would look like with logarithms and exponents. If I take log base a of a to the x, the log and the exponent cancel to just give you x. And then vice versa, f of f inverse. So if I have a raised to the power of log base a. Again, that exponent and logarithm cancel, and you just have x. So exponential function and a logarithmic function, as long as the bases are the same, will cancel out. And then laws of logarithms. Hopefully these look familiar from last year. So if x and y are positive numbers, then if you have a log base a of x times y, so if you have a logarithm of a product, you can rewrite that as the sum of two logs. So that'd be log base a of x plus log base a of y. Log base a of x divided by y, the logarithm of a quotient, is log base a of x minus log base a of y. So it would be the difference of two logarithms. And then log base a of x to a power, r, that power can be brought down in front as a coefficient. So r times log base a of x. Or vice versa. If it is multiplied in front of a logarithm, it can be brought up as an exponent. And these we do use throughout the course, the laws of logs. So you do need to know them. So I have, for example, to use laws of logs to evaluate each expression. So actually practice the laws of logarithms. Don't just type the logarithm expression into your calculator. Practice the laws of logs because you need to know them anyway. So if we have log base 2 of 80 minus log base 2 of 5, so first of all, to use laws of logs, you have to make sure the bases on the logarithms are the same. In this case, they're both 2. So if I have the difference of two logs, then I'm looking at the second law of logarithms. I can rewrite that as a quotient. So I can put it as one logarithm, a quotient. So it would be log base 2 of 80 divided by 5. And then I can actually divide 80 and 5. So log base 2 of 16. And then I can figure out the value of this logarithm like we did under example 1. What would log base 2 of 16 be? 4, yes. Because 2 to the 4th power is equal to 16. So 4 would be the singular value of that expression. Questions on A? All right, so for part B, one thing I want to talk about before we go through it, if you just see log, so no base is written, what base is there actually? 10, yes. So log, it's called the common log, is really log base 10. And your calculator is either in base 10, you have a log key that's base 10, or it's in base E for the natural log. So log base 10, or just log of 50 plus log of 2, how could we rewrite this using laws of logs? Yep, log of 50 times 2. And if you wanted to write base 10 in there, you can. So this would be log of 100, or log base 10 of 100, which is equal to what value? 2, because 10 squared is 100. Questions? Good so far? All right, so as I talked about with exponential functions, I talked about base E being used most commonly in calculus, and I know I gave you that geometric property with the tangent line to the curve, which doesn't really have to mean anything to you right now because we're not in chapter 2 yet, so we will talk about that more when we get there. But this is the same idea. Of all possible bases for a logarithm, the most convenient choice is the number e, and the logarithm with base e is called the natural logarithm and has a special notation. So you won't see log base e of x, it's written as the natural log of x. You can always rewrite it as log base e if that makes more sense to you. but I would really encourage you to get used to the natural log notation because it's used the most often. So then just properties for natural logarithms, which they have the same properties. It's just writing it with natural log versus log base e. So I have here if natural log of x is equal to y, so an exponential notation, that would be e to the y is equal to x. So that's because natural log of x is log base e. So then you can see it's e raised to the power of y should equal x. So that's where that's coming from. So it's specifically the inverse function of e to the x. So that's what it says here for the cancellation equation. So if you have the exponential function f of x equals e to the x, and then f inverse of x equals the natural log of x, e to the x, natural log of x are inverses. They cancel each other out. So if you take the natural log of e to the x, natural log and e cancel to just give you x. If you take e raised to the natural log of x, they cancel to just be x. So you can use each of them to cancel out the other one. And then I do have another property, natural log of e is 1. Anyone know why that is? Yep, e to the 1 is e, so this would be log base e of e is 1, e to the first power is e. That really could be used for any logarithm with base a. So if you have log base a of a, so like log base 2 of 2 or log base 10 of 10, those are all equal to 1. Natural log of e just comes up most often. So I have 4 equations here that involve either logarithms or exponential functions to solve. So if I have the equation natural log of x equals 5, anyone remember how you would solve that? There's really, I guess, a couple of methods you could use for this one. Well, the answer is e to the 5th. And how are you getting?
Oh, is it log e x equals 5?
Yes. So e to the 5th would equal x, or x equals e to the 5th. So one way to solve it would be just to rewrite it in exponential form. Or, so I'm going to kind of go off to the side here, natural log of x equals 5. Another way to solve an equation that has natural log in it is, rather than rewriting it this way, I want to cancel out the natural log, and to cancel out natural log, I don't divide by natural log, but rather I use these cancellation equations. I have to then raise both sides of the equation as powers of e. So I have a base e on both sides. So I'm saying e to the natural log of x equals e to the 5th. Bless you. And on the left side, the e to the natural log cancels out, and you just have x equals, and then I have e to the 5th on the right. So those cancellation equations are often used in solving exponential and logarithmic equations. So 2 different ways you can kind of think about it. And it depends on your equation too, if it's quicker to just rewrite it or maybe quicker to use the cancellation equations. So if we look at example B, we have e to the 5 minus 3x equals 10. So this one, I would also use a cancellation equation to solve. If I want to cancel out my exponential function, I have x in the exponent, I need to get that brought down. I can take the natural log of each side. So I can take the natural, tried to combine my L and my M there. Natural log of the left side equals natural log of the right side. Because then what happens on the left, the natural log and the e cancel, and I just have 5 minus 3x. And now on the right side, I have the natural log of 10. Which just leave that as natural log of 10. Don't type it in your calculator and get the decimal approximation, just leave it. And now I can just solve for x. So I can subtract 5 from each side. So negative 3x equals natural log of 10 minus 5. And make sure the minus 5 is separate from the 10 that is inside of the natural log. And then divide everything by negative 3. So x is, and I could just leave it written that way. I'll leave it written this way. Natural log of 10 minus 5, all divided by negative 3. I was going to say, too, I could write the negative in front if you didn't want to leave the negative in the denominator. This would be the exact answer. I need a new document camera. I've said that before. Strange things are happening. I just hope it's recording right now. Questions on that one? Okay. Are we okay if I skip over C and D right now? So these are very similar to A and B. It's just the natural log and then the e to the power are not alone. So you would first need to get the natural log of x alone or e to the x minus 4 alone before you use the inverse operation to cancel it out. I can come back to those. I just want to, address the last question for sure. And then example 4, this is actually similar to the example 2. It's just this one you have to use laws of logs. You don't have the choice to just type it in your calculator to check if it's right. So it says express natural log of A equals 1/2 natural log of B as a single logarithm. So you're using laws of logs with the natural log to do that. So laws of logs still work if you have natural log. So first of all, because I have this 1/2 in front, I would have to bring that up as the exponent on the B. So I would have natural log of A plus natural log of B to the 1/2 power. Or how else could you write B to the 1/2? The square root of B would also work. And then once you have the two natural logs now added together, neither one of them has a coefficient in front. Now I can apply that property and write it as a product, the natural log of a product. So it'd be natural log of A times B to the 1/2 power, or A times the square root of B. And now I have a single logarithm. Okay, so just making sure you can still use those laws of logs even if you have natural log. Change of base formula. I will, let me decide what time is it here. Exactly, 3:04, okay. Change of base formula, like I said, your calculator is in base 10 or base E for natural log. Either a scientific calculator or hopefully you're using your graphing calculators. I feel like there's a way that you can type in the log of a different base on the graphing calculator, but I'll be honest, I don't. Do you know how? And it might not work for everybody's calculator, I'm not sure. If you have a newer one, it probably does. Oh, where it says log, yeah, log base. Well, there you go. Does everybody have this on theirs? Because that makes the change of base formula unnecessary. Okay, because you have the 83. Okay, so if you have this, there you go. Just make sure you realize you have it if you need to use it. If you don't have it, so it's Melanie in your case, so this is how you would have to type it in your calculator using either the natural log or the log base 10. This doesn't come up too often, but so for example, example 5, log base 8 of 5, I would type that in my calculator either as natural, can't make an L and an N here, natural log of 5 divided by natural log of 8, or log of 5 divided by log of 8. And then you would get the right value.